Baseball, Einstein of the national pastime, and you know it's my favorite time of year, the beginning of baseball season. But before we go there, let's take a time out and think about the forces on a pitched baseball moving at 100 miles an hour. You know there are only three. The first force is gravity, or the weight, pulling the ball down. The second force is drag, which is exactly opposite to the velocity. The third force is the lift. It's perpendicular to the velocity and the spin axis of the baseball. Let's start with the gravitational force. And to calculate the acceleration due to gravity, I brought along my friend Galileo. It sure is easier to measure the acceleration due to gravity nowadays. This is a G-ball from Arbor Scientific. It has a timer that starts when I let go of the ball and it stops when the ball hits the ground. Alright, let's go time a fall of 1 meter. Oh, let's use this meter stick so we know how far it drops, and we're ready to go. Now my buddy Dr. Baseball can calculate the acceleration due to gravity. Great! We could use a kinematic equation because the acceleration is constant. We'll say the initial position is 0 and the initial speed was certainly 0. Now we can solve for the acceleration. What did you say that time was? Oh yeah! Distance was 1 meter and the time was 0.45 seconds. Let's see, I'm really good at math, so the answer is 9.9 meters per second squared. Wow, that's within 1%. Hey Galileo, you know a fastball travels horizontally. Why don't you try that to see if it affects the acceleration due to gravity? Great idea! It's exactly the same. That's quite remarkable. Maybe I should throw it faster. That's amazing. The very same result. Okay, you caught us. Your results may not be that consistent. In other words, your results may vary, but not by much. Hey Galileo, it was great to see you. Yeah, that was fun. Let's not wait 400 years to do it again. Arrivederci. Hey, I just realized that a baseball might weigh less than the G-ball. Let's see if they both accelerate at the same rate. They both fell at the same rate. What about if I try a bowling ball? Let me go get one. All right, now we're ready. Son of, oh, gee, son, ow. Well, I guess that settles it. Fastball, changeup, or curve, they all fall at the same rate. The acceleration due to gravity, 9.8 meters per second squared. Well, we're out of time. But if you or your students are interested in more physics of baseball activities, you can find them anytime at majorleaguephysics.org.